Hello students, today we're going to talk about segments and congruence. Don't forget to take notes and write down all the examples. Okay, so segment addition postulate is a rule that we have in geometry. A postulate or an axiom is just another name that means a rule that is accepted without proof. Okay, so anytime you see the word postulate, just think of a rule that geometry has. So the postulate we're going to be talking about today is the segment addition postulate. And that tells us that if B is between A and C, then AB plus BC equals AC. Okay, so you can see in the picture, if we have AB right here, and we add that to BC, then we're going to get the whole line AC. Okay, so we're just adding two little parts together to make one whole. Okay, and you can see here when we're talking about the length of different lines, we just note it by the two letters right next to each other. So that doesn't mean multiplication or anything like that. It's just that we use AB to denote the distance between A and B. Okay, so here's our first example. We have XY. We're trying to find XZ, sorry. So we're trying to find this whole length between X and Z. Okay, so we can use the segment addition postulate because we know that to find this whole length, we know that XY plus YZ is going to give us that whole length. So all we got to do is add the two together. Okay, so 23 plus 50 is going to give us 73, which tells me that XZ, or this whole length, is 73. Alright, now, if YW, so this length right here, is 30, can we use the segment addition postulate to find the distance between points W and Z? So can we use the segment addition postulate to find these two, to find this length right here, because we know that this is 30? Nope, we can't. Okay, we can't do that because W is not on XZ. Okay, W is not on the same line, and we don't have a point that's in the middle. Okay, this segment is not on that line. This segment is not on that line, so we can't use that point at all. So we can't find what WZ is with this information. Okay, let's look at another example. Point S is between RT on the line RT. Okay, this is going to make things easier if we make a picture. So draw a picture with me. So we have a straight line, okay, and we have S is between RT. So we want to put S between R and T. So as long as your S is between the two letters, then you're good to go. Alright, now we want to find the lengths of RS and ST. We're going to do that by using these expressions. So we know that RS is 2x plus 10, so we're going to label that. And we know that ST is x minus 4, we're going to label that. And then this whole thing, RT, is 21. Okay, now we want to look at what they're asking us to find. They're asking us to find the lengths of RS and ST. Okay, so make sure we pay attention to that. Think about that as we go through this. Okay, so RS and ST, well, we know that S lies between RT, so we can use the segment addition postulate and add these two together to get the whole thing. So we're going to add our RS plus our ST to equal the whole thing RT. Okay, once we set that up, we're just solving equations now. So we want to combine our like terms. So 2x plus x is 3x. 10 minus 4 is a positive 6. And that's going to equal 21. Alright, subtract 6 from both sides. So we're left with 3x equals 15. Divide by 3. So we're left with x equals 5. Now, is this our answer? No. Okay, remember it's asking us to find the length of RS and ST. This is just what X is. Okay, so now to actually find those lengths, we're going to substitute X in for this X and in for this X in these lengths. Okay, so for RS, it's 2x plus 10. So we're going to go 2 times 5 plus 10. And we can type that directly into our calculators. So 2 times 5 plus 10 is going to give us 20. Okay, and then for ST, that's x minus 4. So if we put 5 in for x, 5 minus 4 is 1. So the length of RS is going to be 20, and the length of ST is going to be 1. Okay, so we had to find x in order to find those lengths, but x equals 5 is not our answer. We have to make sure we answer that question. Alright, so congruence versus equality. Equals being the same in quantity, degree, or value. So like 4 equals 4. It's the same exact number. Okay? Congruence is identical in form, shape, or size. So if we say that 2 segments are congruent, that means they have the same length. Okay, so congruent markings, when we're looking at sides, they use these little tick marks. Okay, so 1 tick mark and 1 tick mark means that these two lengths are congruent. Okay, same thing here. This 1 tick mark means that it's congruent to this 1 tick mark. The 2 tick marks is congruent to the 2 tick marks, and so on and so forth. Alright, when we're looking at angles, you either see these kinds of angle markings where you have 1, 2, or 3 little curves in the angle, or you have a curve with a line. So just like with the sides, the one is congruent to the 1, the 2 is congruent to the 2. Alright, so when we're looking at this, we have AB is 6x minus 12, and BC is 3x plus 27. Now these little signs mean that they're congruent, so that means they're the same in length, which means we can set them equal to each other. So 6x minus 12 equals 3x plus 27, because they're the same in their lengths. Okay, now that we set them equal to each other, we just have an equation. So we'll start with our variables. Let's subtract 3x from both sides. So 3x minus 12 equals 27. Add 12 to both sides. So 3x equals 39. Divide by 3 on both sides. So x equals 13. Now, remember at the very beginning, it asked us to find AC. So in order to find AC, this is not AC, this is just x. So we need to substitute our x value back into the x terms. And since B is between AC, we can use the segment addition postulate and add these together. So we have 6 times 13 minus 12 plus 3 times 13 plus 27. Alright? So I'm just substituting 13 back into my x values into both expressions so I can get this whole length AC, because that's the question that they're asking us to find. Alright? Now, in order to get this value, all we're going to do is substitute it into our calculators. Alright, make sure you substitute it correctly. We're multiplying here, so we need to have these parentheses around our 13, because that's the value we substituted in. Go ahead and type that into your calculator. Alright, and once we plug that into our calculators, you should get 132. So, the distance of AC equals 132. Alright, here's another definition. Segment bisector. Okay, so a segment bisector is a line, segment, or ray that splits a segment into 2 congruent parts. Okay, so remember, congruent means that they're telling us that the 2 lines are the same length. So keep that in mind when we're talking about bisectors. The two lines on either side of the bisector is the same length. Okay, so line DE bisects AC. Whoops, sorry. So we see DE and AC in our picture here. Okay, so if AB is 2x, whoop, now I've lost my pen, hold on. 2x plus 4, and AC, so the whole thing, AC, is 40, find the length of BC. Okay, well, we know that DE and AC bisect, so that means that this side is congruent to this side, which they give us those congruency lines that we talked about earlier. So if this side is going to be 2x plus 4, then we know that this side will be 2x plus 4. And if we talk about that segment addition postulate that we had at the beginning, since B is between the two, and we know this whole distance, we can add the two together to equal 40. All right, so we're going to have 2x plus 4 plus 2x plus 4 to equal 40. And now we're back to solving an equation. So 2x plus 2x gives us 4x. 4 plus 4 gives us 8 equals 40. Subtract 8 from both sides. So 4x equals 32. Divide by 4. So x equals 8. All right. Now remember, check what they're asking us to find. They're asking us to find the length of BC. So this is not the length of BC. We need to substitute this in to find BC. Since AB and BC are congruent, just like before, we can use what they gave us for AB. So the 2x plus 4. We're going to substitute 8 in for x. And you can put this directly into your calculator. So 2 times 8 plus 4, which would give us 20. All right, so BC is equal to 20.